Hi everyone, in this video we are going to use dimensional analysis to determine the amount of carbon dioxide's emissions that are basically released into our atmosphere every single year. So essentially we're finally going to be able to do a quantitative analysis on this. So let's just take some numbers from 2015, so our current year. We think that on average there are about 3.3 gigatons of carbon released into our atmosphere per year. So we're going to say in this year 2015, 3.3 gigatons of carbon are released. So what we want to do now is convert that number to grams of carbon dioxide. So put that into a more useful terms, essentially. So what we do is we need to start off with a conversion factor, because otherwise how are we going to do this? So 1 gigaton is equal to 1 times 10 to the 15 grams, okay? So now, start with what we know. We know we have 3.3 gigatons of carbon released every year. So what we need to do is get gigatons out of gigatons and into grams. So we know 1 gigaton is equivalent to 1 times 10 to the 15 grams. Now remember, I have gigatons on the top so that and then I have gigatons on the bottom, and we do this so that we can cancel everything out. So 1 gigaton of carbon is equal to 1 times 10 to the 15 grams of carbon. Now we're in grams of carbon, and we just need to convert to grams of carbon dioxide. So here we use our atomic mass of carbon. So our atomic mass of carbon, this comes directly off our periodic table, is 12.01 grams, and this is of carbon. And now we need to do the same thing for grams of carbon dioxide. So instead here we're going to use our molar mass of carbon dioxide. So all we need to do is add up the atomic mass of carbon, so 12, plus the atomic masses of 2 oxygens, so 2 times 16, which is 32. So we add those two numbers together and we get 44.0 grams of carbon dioxide. So our goal is to get to carbon dioxide. Our grams of carbon cancel out and we're left in grams of carbon dioxide. So all we do is multiply 3.3 times 1 times 10 to the 15th times 44, divide that by 12.01, and we end up with 1.21 times 10 to the 16th grams of carbon dioxide. Now, that is a huge, huge, huge number, but maybe you're not very familiar with grams, so let's try to convert that into a unit that means something more to us. So let's try to take grams and convert that to pounds. And so what we need to do is have one more conversion factor. Well, it turns out that 1 pound is equal to 453.592 grams. So start with what we know. We know we have 1.21 times 10 to the 16th grams of carbon dioxide. We're just trying to convert that to pounds. We're going to draw our little railroad tracks again. Grams of carbon dioxide is on the top here, so we need to have grams of carbon dioxide on the bottom again. Well, we know 453.592 grams are in 1 pound. We take 1.21 times 10 to the 16th, multiply it times 1, divide by 453.592, and we end up with a value of 2.667 times 10 to the 13th pounds of carbon dioxide. So essentially what that means, if that number doesn't mean anything to you, 26 trillion pounds of carbon dioxide are released into the atmosphere every single year. That's a lot, guys. 26 trillion pounds. I mean, oh my gosh, that's so, so bad for us. And we know that carbon dioxide is a greenhouse gas, so you need to be constantly processing. Now that we can put numbers onto this, what does that actually mean? And it's not good news. All right, so now I want you to take a chance at this or try this out. And so let me give you a problem to work on. We know that 6 gigatons of carbon are released into the atmosphere every year, so we're just going to put per year, by burning fossil fuels. It's a lot. 6 gigatons. Ugh, that's a lot. All right, here's my question. What is that 6 gigatons in grams of carbon dioxide? Go. All right, did we get an answer? Hopefully we did. It's essentially the same thing we did before. So you start with what you know. We know we have 6 gigatons of carbon. We're going to convert gigatons into grams. So 1 gigaton of carbon is equal to 1 times 10 to the 15th grams of carbon, a lot. Now we're in grams of carbon, so we need to put grams of carbon at the bottom. We use the atomic mass, 12.01 grams of carbon, all to now we're converting to our grams of CO2, so we use our molar mass here, so we have 44.0 grams, and so now our gigatons of carbon cancels out with gigatons of carbon. Grams of carbon cancels out with grams of carbon, and we're left with grams of carbon dioxide. You multiply this all out, divide by 12, and we end up with 2.2 times 10 to the 16th grams of carbon dioxide. So a lot. lot, a lot, a lot, a lot. That's a lot of carbon dioxide we're releasing into the air just by burning fossil fuels. And this is just per year. This isn't total, this is per year. All right, let's try one more. A little bit harder now. So we're going to say 142 times 10 to the 6 tons of sulfur dioxide, SO2, is released by burning fossil fuels. So a pollutant. Fossil fuels. Okay, so this is the fossil fuel combustion. I want you to convert this number right here to grams of sulfur. And I'm going to give you one conversion so you don't have to look it up. 1 ton is equal to 1 million grams. Go. All right, did you get an answer? Hopefully you did, but if you didn't, let's work through this together. Always start with what you know. So 142 times 10 to the 6 tons of SO2. We've got to get it out of tons. Tons is an awful unit for us. So 1 ton of SO2 is equal to 1 million grams of SO2. Now we're in grams of SO2, but we're trying to get to grams of sulfur. So grams of SO2 will be on the bottom, grams of sulfur will be on the top. So we know that the molar mass of SO2 is going to be 64.06 grams. Where did I get that number? We have the atomic mass of sulfur, which is about 32, and then we have the atomic mass of oxygen. It's 16 per each oxygen atom, so 32 total. 32 plus 32 gives us a value of 64. Now, our atomic mass of sulfur is just 32.06 if we want to be specific. So now let's check our units. Tons of sulfur dioxide cancels out with tons of sulfur dioxide. Grams of sulfur dioxide cancels out with grams of sulfur dioxide. We're left in grams of sulfur, which is what we're trying to get. If we multiply this all together, so 142 times 10 to the 6 times 1 million times 32 divided by 64, we get 7.1 times 10 to the 13th grams of sulfur. Great job, guys. Keep up the good work and take care of yourself.